Question 1. To address the challenge of a client requesting a significant cost reduction for an IP telephony system upgrade by suggesting the temporary bypass of certain security hardening procedures during the implementation phase, what is the most professionally responsible course of action for the IT manager? Option A. Refuse the client's request to bypass security hardening procedures without offering any alternative solutions or explanations, citing the need for strict adherence to security protocols. Option B. Agree to bypass the security hardening procedures as a temporary measure, assuring the client that security will be addressed later, and proceed with the upgrade to meet the immediate cost-saving goal. Option C. Explain the security risks associated with bypassing hardening procedures. Propose a phased upgrade plan that incorporates the client's budget constraints while maintaining security. And document the discussion and agreed-upon plan. Option D. Immediately implement the upgrade as requested, bypassing the security hardening procedures to meet the client's cost-saving objective, and plan to address security vulnerabilities in a future maintenance cycle. Correct answer is C. Explain the security risks associated with bypassing hardening procedures. Propose a phased upgrade plan that incorporates the client's budget constraints while maintaining security, and document the discussion and agreed-upon plan. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent conflict between a client's immediate desire for a cost-saving measure and the long-term security and compliance requirements of their IP telephony system. The IT manager is tasked with balancing client satisfaction with their professional responsibility to implement solutions that are secure, reliable, and adhere to industry best practices and potential regulatory guidelines. Though specific regulations are not detailed here, the principle of due diligence applies. The pressure to reduce costs can lead to shortcuts that compromise system integrity. Correct approach analysis. The correct approach involves educating the client on the security implications of their request and proposing a phased implementation of the upgrade that addresses their cost concerns while maintaining security. This aligns with professional best practices by prioritizing system integrity and security. It demonstrates due diligence, a core ethical principle in IT, ensuring that the proposed solution is not only functional but also secure and resilient. By offering a phased approach, the IT manager shows a commitment to finding a workable solution that respects the client's budget without sacrificing essential security protocols. This proactive communication and solution-oriented strategy builds trust and reinforces the IT manager's role as a trusted advisor. Incorrect approaches analysis. One incorrect approach involves immediately agreeing to the client's request to bypass security protocols for the upgrade. This is professionally unacceptable because it directly violates the principle of due diligence and could expose the client's network to significant security vulnerabilities. Such an action would be a failure to uphold professional standards, potentially leading to data breaches, service disruptions, and reputational damage for both the client and the IT manager. It prioritizes short-term cost savings over long-term system security and stability. Another incorrect approach is to refuse the client's request outright without offering any alternative solutions or explanations. While it avoids the immediate security risk, it fails to address the client's underlying concern about cost and can be perceived as uncooperative or lacking in problem-solving skills. This approach can damage the client relationship and may lead the client to seek less scrupulous solutions elsewhere. Professional practice dictates a collaborative approach to problem-solving, not outright refusal without constructive alternatives. A third incorrect approach is to implement the upgrade with the bypass security protocols and then attempt to address security issues later. This is a reactive and irresponsible strategy. It exposes the system to risks during the interim period and places the burden of remediation on future efforts, which may be more complex and costly. This approach demonstrates a lack of foresight and a failure to integrate security into the initial implementation, which is a fundamental tenet of secure system design. Professional reasoning. Professionals in this situation should employ a decision-making process that begins with understanding the client's needs and constraints. This is followed by an assessment of the technical and security implications of the request. The next step involves transparent communication with the client, clearly explaining the risks and benefits of different approaches. The professional should then propose solutions that balance client requirements with professional obligations, offering alternatives and justifications. This iterative process of understanding, assessing, communicating, and proposing ensures that decisions are informed, ethical, and in the best interest of the client's long-term operational success and security. Question 2. The control framework reveals a need to analyze call detail records, CDR, to diagnose intermittent call quality issues within the Cisco IP telephony and video deployment. A senior engineer, frustrated by the slow progress of the official support ticket, considers bypassing the standard data access request procedure. They believe they can quickly identify the root cause by directly accessing the CDR database and manually sifting through recent call logs for the affected users. What is the most professionally responsible course of action? Option A. Submit a formal request for access to the CDR data, specifying the exact timeframes and user groups required for troubleshooting, and await authorization before proceeding. Option B. Share the raw CDR data with a wider team of network engineers for collaborative analysis, hoping a fresh set of eyes will expedite the troubleshooting process. Option C. Immediately access the CDR database directly, manually review the logs for the affected users, and document any findings for the support ticket. Option D. Proceed with the manual review of CDRs without formal request, assuming that troubleshooting is a priority that supersedes standard data access protocols in urgent situations. The correct answer is C. Immediately access the CDR database directly, manually review the logs for the affected users, and document any findings for the support ticket. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical obligation to maintain data privacy and security within a Cisco IP telephony and video environment, specifically concerning call detail records, CDR. The challenge lies in balancing the legitimate business need for troubleshooting and performance analysis with the strict regulatory requirements for data handling and user privacy. The temptation to access sensitive information for expediency, without proper authorization or anonymization, creates a conflict between operational efficiency and compliance. Careful judgment is required to navigate this conflict by adhering strictly to established protocols and regulatory mandates. Correct approach analysis. The correct approach involves strictly adhering to the established data access and privacy policies, which are informed by relevant regulatory frameworks. In the context of the CIPTV2 exam, this implies understanding and applying principles related to data protection and lawful access. Best professional practice dictates that any access to sensitive CDR data for troubleshooting must be performed by authorized personnel within a defined scope and with appropriate anonymization or aggregation techniques applied where possible. This ensures that individual privacy is protected while still allowing for necessary operational insights. The regulatory justification stems from the need to comply with data protection laws that govern the collection, storage, and processing of personal data, including communication metadata. Unauthorized or indiscriminate access to CDRs would violate these principles, potentially leading to significant legal and reputational damage. Incorrect approach is analysis. Accessing CDRs directly and without authorization for a quick, ad hoc analysis, even with good intentions, represents a significant regulatory and ethical failure. This approach bypasses established security controls and privacy safeguards, violating the principle of least privilege and potentially exposing sensitive user information. Directly contravenes data protection regulations that mandate strict access controls and purpose limitation for personal data. Sharing raw, unanonymized CDR data with a broader team, even for collaborative troubleshooting, is also professionally unacceptable. This broad dissemination increases the risk of data breaches and unauthorized use, as not all individuals in the broader team may have a legitimate need to know or the necessary training in data handling. This violates the principle of data minimization and confidentiality, exposing the organization to regulatory penalties for inadequate data protection measures. Ignoring the potential privacy implications of CDR data and proceeding with analysis without considering anonymization or aggregation techniques is a failure to uphold ethical responsibilities. While the intent might be purely technical, the outcome can be a violation of privacy rights. This demonstrates a lack of due diligence in understanding the sensitive nature of the data being handled and the regulatory obligations associated with it. Professional reasoning. Professionals in this field must adopt a decision-making framework that prioritizes compliance and ethical conduct. This involves 1. Understanding the regulatory landscape. Familiarize oneself with all applicable data protection laws and industry-specific regulations relevant to IP telephony and video communications. 2. Adhering to organizational policies. Strictly follow internal data access, privacy, and security policies. 3. Seeking authorization. Always obtain proper authorization before accessing any sensitive data. 4. Applying the principle of least privilege. Access only the data necessary for the specific task. 5. Employing anonymization and aggregation. Utilize techniques to protect individual privacy when raw data is not strictly required. 6. Documenting all actions. Maintain clear records of data access and processing activities. 7. Consulting with privacy and legal teams. When in doubt, seek guidance from subject matter experts. Question 3. Quality control measures reveal a potential security vulnerability in the configuration of a Cisco Unified Communications Manager (CUCM) cluster that could allow unauthorized access to call detail records (CDR). The system is critical for daily business operations, and the Change Control Board meets only bi-weekly. The administrator has identified a configuration change that would mitigate the vulnerability. What is the most appropriate course of action for the network administrator? Option A. Ignore the vulnerability, as the CUCM system is complex and the risk of disruption from a change is too high. Option B. Document the vulnerability and its potential impact, then submit a change request to the Change Control Board for approval and implementation during the next scheduled maintenance window. Option C. Publicly disclose the vulnerability on a security forum to alert other organizations and the vendor. Option D. Immediately implement the configuration change to address the security vulnerability, as it poses an immediate risk. The correct answer is B. Document the vulnerability and its potential impact, then submit a change request to the Change Control Board for approval and implementation during the next scheduled maintenance window. Explanation. Scenario analysis. This scenario presents a professional challenge where a network administrator discovers a potential security vulnerability in a Cisco Unified Communications Manager (CUCM) configuration that could impact the confidentiality and integrity of voice communications. The challenge lies in balancing the immediate need to address the vulnerability with the potential disruption to business operations and the established change management processes. Careful judgment is required to determine the most appropriate and compliant course of action. Correct approach analysis. The correct approach involves documenting the vulnerability, assessing its impact, and then following the established change management process to implement a fix. This aligns with best professional practices for network administration and IT security. Specifically, it adheres to the principles of responsible disclosure and systematic problem solving. In the context of Cisco IP telephony, this means ensuring that any configuration changes are tested, approved, and implemented in a controlled manner to prevent unintended consequences, such as service outages or further security breaches. This methodical approach minimizes risk and ensures accountability. Incorrect approach is analysis. One incorrect approach is to immediately implement a fix without proper authorization or documentation. This bypasses critical change management procedures, which are often in place to prevent service disruptions and ensure that changes are reviewed by relevant stakeholders. Such an action could lead to unexpected system instability, violate organizational policies, and potentially introduce new, unforeseen issues. It demonstrates a lack of adherence to established IT governance and risk management frameworks. Another incorrect approach is to ignore the vulnerability due to the perceived complexity of the CUCM system or the potential for disruption. This is a failure of professional responsibility and a significant security risk. It neglects the duty to protect the integrity and confidentiality of the organization's communication systems, potentially exposing sensitive voice data to unauthorized access or manipulation. This inaction could have severe legal and reputational consequences for the organization. A third incorrect approach is to disclose the vulnerability publicly without first attempting to resolve it internally or notifying the vendor. This is often referred to as full disclosure, and while sometimes a last resort, is generally considered irresponsible when a more controlled resolution is possible. Premature public disclosure can alert malicious actors to the vulnerability, increasing the risk of exploitation before a patch or mitigation can be deployed. This violates ethical guidelines for responsible vulnerability management. Professional reasoning. Professionals should adopt a structured decision-making process that prioritizes risk assessment, adherence to policy, and collaboration. When a potential vulnerability is identified, the first step is to thoroughly document the findings and assess the potential impact. This assessment should inform the urgency of the response. Subsequently, all proposed solutions must be evaluated against organizational policies, including change management and security protocols. If a solution requires system modification, it must be implemented through the approved change control process, which typically involves testing in a lab environment, obtaining necessary approvals, and scheduling the change during a maintenance window to minimize disruption. Communication with relevant stakeholders, including management and potentially the vendor, is crucial throughout the process. Question 4. Benchmark analysis indicates that a network administrator needs to examine call detail records, CDR, and potentially recorded conversations to diagnose intermittent quality issues affecting IP telephony and video calls. The administrator has access to tools that can extract this data directly from the Cisco Unified Communications Manager, CUCM, and Cisco Telepresence infrastructure. The organization operates under U.S. federal regulations governing telecommunications data privacy. What is the most ethically and regulatorily sound approach for the administrator to take when performing this diagnostic analysis? Option A. Directly access and analyze the raw CDRs and recorded conversations, as the need for network diagnostics supersedes privacy concerns in this context. Option B. Anonymize or pseudonymize sensitive fields within the CDRs and any recordings before conducting the performance analysis, ensuring that personally identifiable information is removed or obscured. Option C. Refrain from analyzing the sensitive call data altogether due to privacy concerns, and instead rely solely on general network performance metrics that do not involve call content or subscriber details. Option D. Share the raw CDRs and recorded conversations with a third-party vendor for analysis, assuming they have the necessary expertise to diagnose the issues without requiring direct access to sensitive data. The correct answer is B. Anonymize or pseudonymize sensitive fields within the CDRs and any recordings before conducting the performance analysis, ensuring that personally identifiable information is removed or obscured. Explanation. This scenario presents a professional challenge rooted in the ethical obligation to maintain data privacy and security within the context of IP telephony and video deployments, specifically concerning the handling of sensitive call detail records, CDR, and potentially recorded conversations. The core dilemma lies in balancing the need for network performance analysis and troubleshooting with the imperative to protect user information from unauthorized access or misuse. The correct approach, which involves anonymizing or pseudonymizing sensitive data before analysis, represents best professional practice because it directly aligns with the principles of data minimization and privacy by design, fundamental tenets in modern data protection regulations. By removing or obscuring personally identifiable information, PI, from CDRs and recordings, the organization upholds its commitment to user privacy, mitigates the risk of data breaches, and complies with regulatory requirements that mandate the protection of such data. This proactive measure ensures that even if the analyzed data were compromised, the risk to individuals would be significantly reduced. An incorrect approach that involves direct access to raw, unanonymized CDRs and call recordings for performance analysis poses significant regulatory and ethical failures. This directly violates data privacy principles by exposing sensitive user information without a clear, legitimate, and documented need that outweighs the privacy risks. Such an action could lead to severe penalties under data protection laws, reputational damage, and a loss of user trust. Furthermore, it demonstrates a lack of due diligence in implementing security controls and a disregard for the ethical responsibility to protect confidential information. Another incorrect approach, which is to ignore potential performance issues due to privacy concerns, is also professionally unacceptable. While privacy is paramount, neglecting network performance can lead to service degradation, impacting user experience and business operations. This approach fails to strike a necessary balance and can be seen as an abdication of responsibility for maintaining a functional and reliable communication system. The professional decision-making process for similar situations should involve a risk-based assessment. First, clearly define the business need for the data analysis. Second, identify the types of sensitive data involved and the potential privacy risks. Third, explore and implement technical and organizational measures to mitigate these risks, such as anonymization, pseudonymization, access controls, and data masking. Fourth, ensure that any data access is logged, audited, and restricted to authorized personnel on a need-to-know basis. Finally, consult with legal and compliance teams to ensure adherence to all applicable regulations and ethical guidelines. Question 5. Consider a scenario where a critical IP telephony service experiences a complete outage impacting all users. The network administrator is under immense pressure from management to restore service immediately. The administrator has identified a potential configuration issue that could be resolved with a quick command line adjustment, but the standard change control process requires a minimum of 2 hours for review and approval, which is not feasible given the business impact. What is the most professionally responsible course of action? Option A. Inform management that service cannot be restored until the full change control process is completed, even if it means prolonged downtime. Option B. Escalate the issue to senior management, requesting an emergency waiver of the change control process for the identified fix while simultaneously preparing a detailed rollback plan. Option C. Bypass the change control process entirely and implement the configuration change, focusing solely on restoring service without any immediate documentation or follow-up. Option D. Implement the configuration change immediately to restore service, and then document the change and submit it for retrospective approval, clearly noting the emergency nature of the action. The correct answer is D. Implement the configuration change immediately to restore service, and then document the change and submit it for retrospective approval, clearly noting the emergency nature of the action. Explanation. This scenario presents a common challenge in network operations, balancing the need for rapid troubleshooting and service restoration with the imperative to maintain system integrity and adhere to established operational procedures. The pressure to resolve a critical voice service outage quickly can lead to shortcuts that, while seemingly expedient, can introduce further instability, violate security policies, or compromise audit trails. The core professional challenge lies in making informed decisions under duress, prioritizing action that are both effective in the short term and compliant with long-term operational and regulatory requirements. The correct approach emphasizes a structured, documented, and controlled method for addressing the outage. This aligns with best practices for incident management, which typically involve clear escalation paths, root cause analysis, and change control processes. By following these established procedures, even under pressure, the network administrator ensures that any actions taken are traceable, auditable, and have undergone appropriate review, minimizing the risk of unintended consequences. This methodical approach is crucial for maintaining the overall health and security of the IP telephony infrastructure, which is often subject to stringent service level agreements and regulatory compliance mandates. An incorrect approach that bypasses established change control procedures, even with good intentions, represents a significant regulatory and ethical failure. Such actions undermine the integrity of the audit trail, making it difficult to reconstruct events and identify the true root cause of the outage. This can lead to repeat incidents and hinder future problem-solving efforts. Furthermore, unauthorized or undocumented changes can introduce security vulnerabilities, potentially exposing sensitive voice data or disrupting critical communication services, which could have severe legal and financial repercussions. Another incorrect approach, such as making broad, untested configuration changes without a clear understanding of their impact, demonstrates a lack of due diligence and a disregard for the potential for cascading failures. This unprofessional behavior not only exacerbates the immediate problem, but also erodes trust in the IT team's ability to manage the network responsibly. Professionals facing similar situations should employ a decision-making framework that prioritizes adherence to established incident management and change control policies. This involves 1. Acknowledging the urgency but not allowing it to override fundamental procedures. 2. Clearly documenting the problem and the initial troubleshooting steps. 3. Consulting documented procedures and seeking assistance from senior personnel or specialized teams if necessary. 4. If an emergency change is absolutely required, ensuring it is documented as thoroughly as possible, even if retrospective approval is needed, and that a rollback plan is in place. 5. Focusing on identifying the root cause to prevent recurrence, rather than just applying a temporary fix. Question 6. The investigation demonstrates that a new branch office requires a robust and efficient call routing strategy to connect to the main headquarters and other remote sites. The current proposed dial plan is a single-level structure that directly maps extensions to specific gateways. This approach, while simple, has shown in simulations to be susceptible to call setup failures if a particular gateway experiences an outage, and it does not inherently prioritize more direct or cost-effective call paths when multiple options exist. The IT team is considering alternative dial plan designs to improve resilience and optimize call flow. Which of the following dial plan design approaches best addresses the need for resilience and efficient call routing in this scenario? Option A. Utilize a flat dial plan where each extension is directly associated with a single, dedicated gateway for simplicity. Option B. Implement a hierarchical dial plan with route lists that include multiple gateways, prioritizing direct routes and providing redundant paths for call termination. Option C. Configure the dial plan to route all calls through a central mediation server, regardless of the destination, to ensure consistent processing. Option D. Design a deeply nested dial plan with numerous translation patterns to accommodate every possible call scenario individually. The correct answer is B. Implement a hierarchical dial plan with route lists that include multiple gateways, prioritizing direct routes, and providing redundant paths for call termination. Explanation. The investigation demonstrates a common challenge in IP telephony deployments, balancing the need for efficient call routing and resource utilization with the imperative to maintain service quality and compliance. The scenario is professionally challenging because it requires a deep understanding of how call processing logic impacts user experience and network performance, particularly when dealing with potential congestion or unexpected traffic patterns. Careful judgment is required to select a call routing strategy that is both technically sound and adheres to operational best practices without introducing unnecessary complexity or single points of failure. The correct approach represents best professional practice because it prioritizes a robust and resilient call routing design. By implementing a hierarchical dial plan with appropriate translation patterns and route lists, the system can efficiently direct calls to their intended destinations while providing fallback options. This design minimizes the risk of call failures due to localized issues and ensures that calls are routed through the most optimal paths, thereby enhancing user experience and service availability. This aligns with the general principles of network design and implementation that emphasize redundancy, scalability, and fault tolerance, which are implicitly expected in professional IT environments. An incorrect approach that relies solely on a flat dial plan without considering redundancy or path optimization introduces significant risks. This could lead to call setup failures if a specific gateway or trunk becomes unavailable, directly impacting business operations and user productivity. Such a design fails to demonstrate due diligence in anticipating potential network disruptions and implementing mitigation strategies, which is a core professional responsibility. Another incorrect approach that involves overly complex or deeply nested dial patterns, while potentially offering granular control, can become difficult to manage, troubleshoot, and scale. This complexity increases the likelihood of configuration errors and can hinder rapid problem resolution during critical incidents, deviating from the professional standard of maintaining clear, manageable, and efficient system configurations. A further incorrect approach that neglects to consider the impact of call routing on quality of service. CoS parameters like latency and jitter can lead to a degraded user experience, even if calls are successfully connected. This oversight fails to address the holistic requirements of IP telephony, which extends beyond mere call establishment to encompass the quality of the communication itself. The professional reasoning process for similar situations should involve a thorough assessment of business requirements, network topology, traffic patterns, and potential failure points. Professionals should then design a call routing strategy that is scalable, resilient, and easily manageable, prioritizing clarity and efficiency. This involves a layered approach to dial plan design, incorporating redundancy and fallback mechanisms, and ensuring that the chosen routing strategy supports optimal CoS. Continuous monitoring and periodic review of the dial plan are also essential to adapt to changing network conditions and business needs. Question 7. Upon reviewing the current IP telephony infrastructure and the desire to enhance call routing capabilities and voicemail integration within the organization, Which of the following strategies best addresses the implementation of advanced features like Cisco Unified Communications Manager, CUCM, call routing, and Cisco Unity Connection, CUC, voicemail integration, considering user adoption and operational impact? Option A. Focus solely on configuring the most complex CUCM call routing scenarios and advanced CUC voicemail features, assuming users will adapt to the new functionalities with minimal guidance. Option B. Implement a phased rollout of advanced CUCM call routing features and CUC voicemail integration, starting with pilot groups and progressively expanding based on user feedback and operational readiness, while ensuring comprehensive training and support are provided at each stage. Option C. Prioritize the integration of CUC voicemail with external email systems before addressing any advanced CUCM call routing configurations, as this is perceived as a higher user priority. Option D. Immediately deploy all advanced CUCM call routing features and CUC voicemail integration across the entire organization to leverage the full capabilities of the new systems as quickly as possible. Correct answer is B. Implement a phased rollout of advanced CUCM call routing features and CUC voicemail integration, starting with pilot groups and progressively expanding based on user feedback and operational readiness, while ensuring comprehensive training and support are provided at each stage. Explanation. This scenario presents a common challenge in IP telephony deployments, balancing the need for advanced features with the practical limitations and regulatory considerations of the existing infrastructure and user base. The professional challenge lies in identifying a solution that is technically sound, cost-effective, and compliant with relevant regulations, while also meeting the diverse needs of different user groups. Careful judgment is required to avoid over-engineering, under-delivering, or introducing compliance risks. The correct approach prioritizes a phased rollout and user-centric design, ensuring that the implementation of advanced features like Cisco Unified Communications Manager, CUCM, call routing, and Cisco Unity Connection, CUC, voicemail integration is aligned with user readiness and business impact. This approach demonstrates best professional practice by adhering to a structured deployment methodology, minimizing disruption, and maximizing user adoption. It also implicitly supports regulatory compliance by ensuring that any new functionalities are properly tested and documented before widespread deployment, reducing the risk of unintended consequences that could violate service-level agreements or data privacy regulations. An incorrect approach that immediately deploys all advanced features without adequate assessment risks overwhelming users, leading to poor adoption and increased support costs. This could also inadvertently violate service availability regulations if the infrastructure cannot reliably support the new features. Another incorrect approach, focusing solely on the technical capabilities of CUCM and CUC without considering user needs or existing infrastructure limitations, is professionally unsound. It ignores the practical realities of deployment and user acceptance, potentially leading to a solution that is technically functional but operationally ineffective and costly to maintain. Furthermore, a failure to consider the impact on existing workflows or regulatory requirements for call recording or data retention could lead to non-compliance. The professional reasoning process for similar situations should involve a thorough stakeholder analysis, including end users, IT support, and management, to understand their requirements and concerns. A risk assessment should be conducted to identify potential technical, operational, and regulatory challenges. A phased implementation plan with clear objectives and success metrics for each phase is crucial. This iterative approach allows for adjustments based on feedback and performance, ensuring that the final solution is robust, user-friendly, and compliant. Question 8. The assessment process reveals that a US-based enterprise is implementing a Cisco IP telephony and video solution. The IT team is debating the most critical factor in designing and implementing the quality of service (QoS) strategy for voice and video traffic to ensure optimal performance and adherence to US telecommunications service standards. Which of the following considerations is paramount? Option A. Designing a QoS policy based on the perceived importance of different departments within the organization, without explicit consideration for regulatory mandates on service quality. Option B. Implementing the most advanced QoS features available in Cisco iOS to maximize bandwidth utilization across all network segments, regardless of traffic type. Option C. Ensuring the Co-S strategy prioritizes voice and video traffic through appropriate classification, marking, queuing, and policing mechanisms, and that this prioritization aligns with the expected quality and reliability mandated by U.S. regulatory bodies for telecommunication services. Option D. Focusing solely on the technical implementation of Co-S without consulting any specific U.S. regulatory guidelines, assuming that good technical practice inherently satisfies all legal requirements. The correct answer is C. Ensuring the Co-S strategy prioritizes voice and video traffic through appropriate classification, marking, queuing, and policing mechanisms, and that this prioritization aligns with the expected quality and reliability mandated by U.S. regulatory bodies for telecommunication services. Explanation. The assessment process reveals a common challenge in implementing Cisco IP telephony solutions, ensuring that the chosen quality of service, Co-S strategy, aligns with both technical requirements and the specific regulatory landscape governing telecommunications in the United States. This scenario is professionally challenging because a misstep in Co-S configuration can lead to degraded call quality, impacting user experience and potentially violating service-level agreements, SLAs, or even regulatory mandates for service availability and quality. The chosen Co-S approach must be technically sound, scalable, and compliant with relevant U.S. regulations, such as those overseen by the Federal Communications Commission, FCC, concerning the provision of telecommunications services. The correct approach represents best professional practice because it prioritizes a comprehensive understanding of the network's traffic patterns and the specific needs of voice and video applications, while also considering the legal and regulatory obligations. Implementing a Co-S strategy that prioritizes voice and video traffic through mechanisms like classification, marking, queuing, and policing, and then validating this implementation against U.S. regulatory expectations for reliable telecommunications services, ensures both technical efficacy and legal compliance. This proactive approach minimizes the risk of service disruption and regulatory scrutiny. An incorrect approach that focuses solely on bandwidth allocation without considering traffic prioritization would fail to meet the technical demands of real-time communication, leading to jitter, latency, and packet loss, which can be interpreted as a failure to provide adequate service quality under U.S. telecommunications law. Another incorrect approach that ignores the regulatory framework entirely, even if technically sound, risks noncompliance with FCC directives or other relevant U.S. statutes governing the quality and reliability of telecommunications services. This could result in fines or other enforcement actions. A third incorrect approach that implements a complex Co-S policy without proper documentation or testing, even if it appears to work initially, is professionally unsound as it lacks the auditability and predictability required for ongoing management and regulatory oversight. Professionals should employ a decision-making framework that begins with a thorough understanding of the project's technical objectives and the specific regulatory environment. This involves researching applicable U.S. telecommunications laws and FCC guidelines related to service quality. Next, they should analyze the network's traffic characteristics and the criticality of voice and video services. Based on this analysis, they should design a Co-S strategy that balances technical performance with regulatory compliance. Finally, rigorous testing and validation, including documentation that clearly articulates how the Co-S implementation meets both technical and regulatory requirements, are essential steps before deployment and for ongoing compliance. Question 9. Examination of the data shows that a company is implementing a new Cisco IP telephony and video solution. The network infrastructure supports both critical voice and video traffic, as well as general data traffic. The project manager is concerned about ensuring the quality of voice and video calls, especially during periods of high network utilization. The lead network engineer is tasked with configuring quality of service, Co-S, to prioritize this traffic. What is the most professional and compliant approach to configuring Co-S in this scenario? Option A. Implement a standard Co-S configuration based on general industry best practices for voice and video traffic, assuming that this will meet the business's needs without further consultation. Option B. Focus solely on the technical aspects of Co-S configuration, such as diff-serve and queuing mechanisms, without consulting business stakeholders, to ensure the most technically optimal solution is deployed. Option C. Prioritize cost-effectiveness by implementing a minimal COS configuration that only addresses the most basic prioritization, as the business has not explicitly stated a need for premium voice and video quality. Option D. Engage key business stakeholders to understand their specific requirements for voice and video quality, document the agreed-upon service levels, and then design and implement a COS strategy that prioritizes these critical traffic types based on those documented requirements, ensuring thorough testing and validation. The correct answer is D. Engage key business stakeholders to understand their specific requirements for voice and video quality, document the agreed-upon service levels, and then design and implement a COS strategy that prioritizes these critical traffic types based on those documented requirements, ensuring thorough testing and validation. Explanation. This scenario presents a common challenge in IP telephony deployment where the technical implementation of quality of service, COS, must align with business needs and regulatory expectations regarding service availability and performance. The professional challenge lies in balancing the technical intricacies of COS configuration with the business impact of potential service degradation, especially for critical communication services. Careful judgment is required to ensure that the chosen COS strategy not only meets technical specifications, but also satisfies the business's service level agreements, SLAs, and any relevant industry guidelines for service continuity. The correct approach represents best professional practice because it prioritizes a thorough understanding of business requirements and potential impact before implementing technical solutions. By engaging stakeholders and documenting the rationale, the engineer ensures that the COS strategy is aligned with business objectives and can be defended against potential scrutiny. This proactive engagement and documentation are crucial for demonstrating due diligence and adherence to professional standards, ensuring that the implemented COS mechanisms effectively support critical voice and video traffic without compromising other essential network services, thereby meeting the implicit regulatory expectation of reliable communication services. An incorrect approach that focuses solely on technical implementation without stakeholder consultation fails to consider the business impact. This could lead to a COS configuration that, while technically sound, negatively affects critical business operations or fails to meet agreed-upon service levels, potentially leading to contractual disputes or regulatory noncompliance if service availability is mandated. Another incorrect approach that prioritizes cost savings over guaranteed performance for critical services is professionally unacceptable. While cost efficiency is important, it should not come at the expense of essential service quality, especially for voice and video communications that are often mission-critical. This approach risks violating implicit regulatory expectations of service reliability and could lead to significant business disruption and reputational damage. A further incorrect approach that relies on outdated or generic COS best practices without specific validation for the current network environment and business needs is also flawed. Network conditions and business requirements evolve, and a static, unverified COS strategy may not be optimal or compliant, leading to suboptimal performance and potential service interruptions. The professional reasoning process for similar situations should involve a structured approach. First, clearly define business requirements and critical services. Second, assess the impact of network performance on these services. Third, research and propose technical solutions that align with both business needs and technical feasibility. Fourth, engage stakeholders to validate the proposed solution and its potential impact. Fifth, document the entire process, including rationale and decisions. And finally, implement and monitor the solution, making adjustments as necessary. This iterative and collaborative process ensures that technical solutions are robust, business-aligned, and professionally defensible. Question 10. Performance analysis shows that a US-based enterprise has recently deployed Cisco Unified Communications Manager, CUCM, and is now tasked with implementing E911 services. The technical team has a general understanding of E911 principles, but needs to ensure the CUCM configuration accurately reflects the requirements for transmitting emergency caller location information to public safety answering points, SAP. Which approach best ensures compliance with US FCC regulations for E911? Option A. Configure CUCM to correctly map emergency service numbers to the appropriate location information, ANI/ALIN, and verify that this data is accurately transmitted to the SAP, adhering strictly to FCC guidelines for E911. Option B. Configure E911 using general VoIP best practices for emergency calling without specifically referencing or verifying against US FCC E911 mandates. Option C. Focus on deploying new collaboration features and address E911 configuration only after these other features are fully operational and tested. Option D. Implement E911 based on the company's internal IT policy for emergency response, assuming it covers all necessary aspects of emergency calling. The correct answer is A. Configure CUCM to correctly map emergency service numbers to the appropriate location information, ANI/ALIN, and verify that this data is accurately transmitted to the SAP, adhering strictly to FCC guidelines for E911. Explanation. Scenario analysis. This scenario presents a common challenge in IP telephony deployments, ensuring compliance with evolving regulatory requirements for emergency services, E911 in the U.S. The professional challenge lies in balancing the technical implementation of a new feature with the absolute necessity of adhering to legal mandates. Failure to correctly configure E911 can have severe legal and ethical consequences, including potential liability in emergency situations. The complexity arises from understanding the specific technical requirements of the regulatory framework and translating them into a functional Cisco Unified Communications Manager, CUCM, configuration. Correct approach analysis. The correct approach involves a thorough understanding and direct application of the relevant U.S. regulatory framework for E911 services, specifically the FCC's rules and guidelines. This means configuring CUCM to correctly associate emergency service numbers, like 911, with the appropriate location information, ANI/ALIN, and ensuring that this information is accurately transmitted to the public safety answering point, SAP. This directly addresses the regulatory mandate to provide reliable emergency calling capabilities for users of the IP telephony system. Best professional practice dictates prioritizing compliance with these life safety regulations above all other considerations. Incorrect approach is analysis. Implementing E911 without explicitly verifying the configuration against the FCC's specific requirements for ANI/ALIN mapping is a significant regulatory failure. This approach risks misrouting emergency calls or providing incomplete location data to SAP, directly violating the spirit and letter of the law. Configuring E911 based solely on internal company policy or general best practices, without referencing the specific FCC mandates, is also a regulatory failure. While internal policies are important, they must align with and often exceed legal requirements. Relying on them alone without validating against the FCC's rules can lead to non-compliance. Prioritizing the implementation of other advanced IP telephony features over the correct and verified configuration of E911 represents a critical ethical and regulatory failure. Life safety regulations for emergency services are paramount and must be addressed first and foremost. Delaying or neglecting E911 in favor of non-essential features is professionally unacceptable and carries significant risk. Professional reasoning. Professionals should adopt a decision-making framework that prioritizes regulatory compliance, especially concerning public safety. This involves 1. Identifying all applicable regulations, e.g., FCC E911 rules. 2. Thoroughly understanding the technical requirements mandated by these regulations. 3. Designing and implementing solutions that directly meet or exceed these requirements. 4. Rigorously testing and verifying the implementation against the regulatory specifications. 5. Documenting the compliance process and configuration. In situations involving life safety services like E911, a compliance-first mindset is essential, overriding other project priorities if necessary. Question 11. Governance review demonstrates that the current administrative access model for the Cisco Unified Communications Manager cluster is overly permissive, posing a significant security risk and potentially violating compliance mandates. The IT security team has proposed several approaches to rectify this situation. Which approach best balances security requirements with operational needs while adhering to best practices for secure IP telephony management? Option A. Disable all administrative access controls within CIPTV2 and rely solely on network-level firewalls to restrict access to the administrative interfaces. Option B. Implement granular role-based access control (RBAC) within CIPTV2, assigning specific administrative privileges based on job function, and enforce secure protocols for remote administrative access with robust authentication mechanisms. Option C. Implement only basic password complexity requirements for all administrative accounts and forego any role-based access or detailed logging. Option D. Grant full administrative privileges to all members of the IT support team to ensure they have the necessary access for troubleshooting and maintenance. The correct answer is B. Implement granular role-based access control (RBAC) within CIPTV2, assigning specific administrative privileges based on job function, and enforce secure protocols for remote administrative access with robust authentication mechanisms. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise IP telephony deployments, balancing the need for robust security with the operational demands of user accessibility and efficient troubleshooting. The core conflict lies in the potential for overly restrictive security measures to impede legitimate administrative tasks, while overly permissive measures create significant vulnerabilities. The professional challenge is to implement security controls that are both effective against threats and practical for day-to-day management, all within the confines of regulatory compliance. Correct approach analysis. The correct approach involves implementing a layered security strategy that leverages the capabilities of Cisco Unified Communications Manager, CIPTV2, to enforce granular access controls. This aligns with best practices for secure network device management and is implicitly supported by general IT security principles that are often reflected in regulatory frameworks requiring data protection and system integrity. Specifically, using role-based access control (RBAC) within CIPTV2 ensures that administrators are granted only the minimum necessary privileges to perform their duties. This principle of least privilege is a cornerstone of modern cybersecurity and is crucial for preventing unauthorized access or accidental misconfiguration. Furthermore, implementing secure protocols for administrative access, such as SSH with strong authentication, and regularly auditing access logs are essential for maintaining a secure and compliant environment. This approach directly addresses the need for both security and operational efficiency by enabling targeted access for specific tasks. Incorrect approach is analysis. Disabling all administrative access controls and relying solely on network-level firewalls is a significant regulatory and ethical failure. This approach creates a wide attack surface, violating principles of data protection and system integrity that are fundamental to most IT regulation. It makes the system highly vulnerable to unauthorized access, data breaches, and service disruptions, which could lead to severe penalties and reputational damage. Granting full administrative privileges to all IT support staff, regardless of their specific roles or responsibilities, is another critical failure. It violates the principle of least privilege, increasing the risk of accidental misconfigurations, malicious insider threats, and unauthorized data access. Such a broad grant of access is incompatible with regulations requiring accountability and control over sensitive systems and data. Implementing only basic password complexity requirements without any form of role-based access or logging is insufficient. While password complexity is a baseline security measure, it does not address the need for granular control over administrative functions or provide the necessary audit trails to demonstrate compliance with security policies and regulations. This approach leaves the system vulnerable to privilege escalation and makes it difficult to investigate security incidents. Professional reasoning. Professionals should adopt a risk-based approach to security, starting with a thorough understanding of the organization's assets, potential threats, and regulatory obligations. This involves conducting a comprehensive security assessment of the IP telephony environment. The decision-making process should prioritize the implementation of security controls that align with the principle of least privilege, utilizing the native security features of the platform, e.g., CIPTV2 RBAC. Regular security audits, vulnerability assessments, and incident response planning are also critical components of a robust security posture. When faced with conflicting requirements between security and operational needs, professionals must seek solutions that achieve an acceptable balance, always erring on the side of caution and compliance. Documentation of all security decisions and configurations is essential for demonstrating due diligence and facilitating future reviews. Question 12. Analysis of a new Cisco Unified Communications Manager (CUCM) feature that logs detailed call metadata, including caller ID, called number, call duration, and timestamp, to a central logging server for troubleshooting and performance analysis. The organization operates within a jurisdiction that mandates strict data privacy regulations, similar to GDPR, requiring explicit user consent for the collection and processing of personal data. What is the most appropriate course of action before enabling this feature across the enterprise? Option A. Conduct a thorough privacy impact assessment to identify potential risks to user privacy and implement appropriate technical and organizational controls, including obtaining explicit user consent for the collection and processing of this metadata. Option B. Rely on existing general data protection policies to cover the collection of call metadata without seeking specific user consent for this new feature. Option C. Deploy the feature with basic network security measures, such as firewall rules, and inform users of the new logging capability through a general IT announcement. Option D. Enable the feature immediately to leverage its troubleshooting benefits, assuming that call metadata is not considered sensitive personal data under current regulations. The correct answer is A. Conduct a thorough privacy impact assessment to identify potential risks to user privacy and implement appropriate technical and organizational controls, including obtaining explicit user consent for the collection and processing of this metadata. Explanation. Scenario analysis. This scenario presents a common challenge in IP telephony deployments where a new feature, while beneficial, has potential implications for user privacy and data handling. The professional challenge lies in balancing the desire to implement advanced functionality with the imperative to comply with data protection regulations. The need for careful judgment arises from the potential for unintended data exposure and the legal ramifications of noncompliance. The complexity is amplified by the distributed nature of IP telephony, where data can traverse multiple network segments and potentially be accessed by various entities. Correct approach analysis. The correct approach involves a thorough risk assessment and the implementation of appropriate security and privacy controls before deploying the feature. This aligns with the principles of data protection by design and by default, which are fundamental to many regulatory frameworks. Specifically, it requires understanding what data is collected, how it is processed, where it is stored, and who has access, implementing encryption for sensitive call metadata, and ensuring that user consent mechanisms are robust and clearly communicated are critical steps. This proactive stance minimizes the risk of privacy breaches and ensures that the deployment adheres to legal and ethical standards, thereby safeguarding user trust and avoiding potential penalties. Incorrect approaches analysis. Deploying the feature without a comprehensive privacy impact assessment and without implementing necessary safeguards is a significant regulatory and ethical failure. This approach demonstrates a disregard for data protection principles and exposes the organization to legal liabilities, fails to consider the potential for unauthorized access or misuse of call metadata, which could include sensitive information. Implementing the feature with only basic security measures, such as standard authentication, without addressing the specific privacy implications of the new functionality, is also insufficient. This overlooks the nuanced requirements of data privacy, which extend beyond mere access control to encompass data minimization, purpose limitation, and transparency. Ignoring user consent or providing vague and misleading information about data collection practices is a direct violation of privacy regulations. Users have a right to know how their data is being used and to provide informed consent. Failure to do so erodes trust and can lead to legal challenges. Professional reasoning. Professionals should adopt a risk-based approach to technology implementation. This involves identifying potential risks, assessing their likelihood and impact, and developing mitigation strategies. When dealing with features that handle personal data, a privacy-by-design methodology is essential. This means integrating privacy considerations into the design and development lifecycle from the outset. Professionals should consult relevant legal and compliance teams to ensure adherence to all applicable regulations. A structured decision-making process would involve 1. Identifying the feature and its data handling implications. 2. Conducting a privacy impact assessment. 3. Evaluating technical and organizational measures for data protection. 4. obtaining necessary consents and ensuring transparency. 5. Documenting the assessment and mitigation strategies. 6. Obtaining approval from relevant stakeholders before deployment. Question 13. Compliance review shows that a proposed implementation of Differentiated Services Code Point (DSCP) marking for voice and video traffic on the Cisco IP telephony and video (CIPTV2) network has not undergone a formal impact assessment. The proposed changes aim to prioritize real-time traffic. Which of the following approaches best mitigates potential risks and ensures regulatory adherence? Option A. Proceed with the DSCP marking implementation as planned, relying on Cisco's best practice recommendations for CO-S to ensure optimal performance. Option B. Deploy the DSCP marking across the entire network immediately to realize the benefits of prioritized traffic, assuming it will improve overall service quality. Option C. Conduct a comprehensive impact assessment that analyzes the effects of DSCP marking on existing voice and video call quality, network resource utilization, and adherence to any applicable telecommunications service quality regulations. Option D. Implement the DSCP marking on a single pilot site and monitor its performance without a broader assessment of potential regulatory implications. Correct answer is C. Conduct a comprehensive impact assessment that analyzes the effects of DSCP marking on existing voice and video call quality, network resource utilization, and adherence to any applicable telecommunications service quality regulations. Explanation. Scenario analysis. This scenario presents a common challenge in network design and implementation, balancing the need for advanced features with the potential impact on existing services and regulatory compliance. The professional challenge lies in accurately assessing the ripple effects of introducing a new technology, specifically quality of service, CO-S policies, on a Cisco IP telephony and video (CIPTV2) environment. Without a thorough impact assessment, the organization risks service degradation, non-compliance with service-level agreements (SLAs), and potential breaches of regulatory requirements related to telecommunications service availability and quality. The complexity arises from the interconnectedness of network components and the sensitive nature of real-time voice and video traffic. Correct approach analysis. The correct approach involves a comprehensive impact assessment that meticulously analyzes how the proposed CO-S policies will affect existing voice and video traffic, network infrastructure, and critical services. This assessment must consider potential bandwidth contention, latency, jitter, and packet loss implications for all real-time applications. It should also evaluate the compatibility of the proposed CO-S mechanisms with existing Cisco Unified Communications Manager (CUCM) configurations, Cisco iOS gateways, and any integrated video conferencing systems. Furthermore, the assessment must verify that the implemented CO-S will not inadvertently violate any regulatory mandates concerning service quality, availability, or data privacy, particularly if the organization operates in a regulated industry. This proactive, detailed analysis ensures that the CO-S implementation is not only technically sound, but also compliant and beneficial to overall service delivery. Incorrect approaches analysis. Implementing CO-S without a prior impact assessment is a significant regulatory and ethical failure. It demonstrates a disregard for due diligence and a lack of professional responsibility in managing critical network infrastructure. This approach risks disrupting essential communication services, potentially leading to financial losses, reputational damage, and non-compliance with service-level agreements. Deploying CO-S based solely on vendor recommendations without considering the specific network environment and existing services is also professionally unacceptable. While vendor guidance is valuable, it is generic, failing to tailor the implementation to the unique operational context and regulatory landscape can lead to unforeseen negative consequences. This approach neglects the critical step of verifying compliance with local telecommunications regulations and internal policies, focusing only on the technical configuration of CO-S on the Cisco devices, without considering the end-to-end impact on voice and video quality and potential regulatory implications, is another flawed strategy. This narrow technical focus ignores the broader service delivery and compliance requirements. It fails to address how the CO-S changes might affect user experience or contravene any legal obligations related to service quality. Professional reasoning. Professionals should adopt a structured, risk-based approach to network changes. This involves 1. Understanding the business and regulatory context. Identify all relevant laws, regulations, and internal policies that govern telecommunication services. 2. Defining clear objectives. What is the intended outcome of the COS implementation? 3. Conducting a thorough impact assessment. Analyze all potential technical, operational, and compliance implications. This includes simulating traffic patterns and testing under various load conditions. 4. Developing a phased implementation plan. Roll out changes incrementally with clear rollback procedures. 5. Continuous monitoring and validation. After implementation, actively monitor network performance and compliance metrics to ensure objectives are met and no unintended consequences arise. 6. Documentation. Maintain detailed records of the assessment, implementation, and ongoing monitoring for audit and future reference. Question 14. Strategic planning requires a thorough understanding of how proposed changes will affect the existing operational environment. When implementing a new Cisco IP telephony and video solution, which of the following actions best demonstrates a commitment to minimizing disruption and ensuring successful integration? Option A. Conducting a comprehensive impact assessment that evaluates the effects on network infrastructure, user workflows, security posture, and existing applications before deployment. Option B. Relying solely on vendor documentation and default configurations to guide the implementation process, assuming minimal impact on the current setup. Option C. Proceeding with the implementation immediately to leverage the new features as soon as possible, addressing any issues that arise post-deployment. Option D. Prioritizing the deployment of core telephony features first and deferring the integration of video capabilities until a later phase to reduce initial complexity. The correct answer is C. Proceeding with the implementation immediately to leverage the new features as soon as possible, addressing any issues that arise post-deployment. Explanation. The scenario presents a common challenge in IT project management, balancing the need for rapid deployment with the imperative of thorough impact assessment. In the context of implementing Cisco IP telephony and video solutions, a failure to adequately assess the impact of changes on existing infrastructure, user workflows, and critical business operations can lead to significant disruptions, security vulnerabilities, and non-compliance with service-level agreements. The professional challenge lies in identifying potential downstream effects that might not be immediately apparent, such as the strain on network bandwidth, the need for user retraining, or the compatibility issues with legacy systems. The correct approach emphasizes a proactive and systematic evaluation of all potential consequences before implementation. This aligns with best professional practices for IT project management, which prioritize risk mitigation and ensuring business continuity. By conducting a comprehensive impact assessment, project teams can identify potential problems early, develop mitigation strategies, and ensure that the new IP telephony and video solution integrates seamlessly with the existing environment. This approach minimizes the likelihood of unexpected downtime, security breaches, and user dissatisfaction, ultimately leading to a more successful and cost-effective deployment. An incorrect approach that bypasses or inadequately performs the impact assessment risks several regulatory and ethical failures. For instance, failing to assess the impact on network capacity could lead to service degradation, potentially violating service-level agreements, SLAs, with internal or external stakeholders, which can have contractual and financial repercussions. Neglecting to assess the impact on user workflows could result in decreased productivity and increased support calls, demonstrating a lack of consideration for the end users and potentially violating internal policies regarding user support and training. Furthermore, overlooking security implications during an impact assessment could expose the organization to vulnerabilities, which, depending on the industry and data handled, could lead to breaches of data privacy regulations or industry-specific compliance standards. Professionals should adopt a decision-making framework that prioritizes a structured and iterative impact assessment process. This involves clearly defining the scope of the assessment, identifying all stakeholders, and systematically evaluating the potential effects on technology, processes, and people. The assessment should be a collaborative effort, involving input from network engineers, security teams, application owners, and end-user representatives. Regular reviews and updates to the impact assessment throughout the project lifecycle are crucial to adapt to any changes or new information. This methodical approach ensures that all potential risks are identified and addressed, leading to a robust and compliant implementation. Question 15. The performance metrics show a significant increase in UDP traffic originating from a specific internal IP address, coinciding with a surge in reported call quality issues and dropped video conferences. A security alert has been triggered for potential unauthorized network activity from this same IP. What is the most appropriate initial course of action? Option A. Immediately block all UDP traffic originating from the suspected internal IP address at the firewall to contain any potential security threat. Option B. Disable the firewall rule that triggered the security alert to prevent further interruptions to network traffic and investigate the alert later. Option C. Escalate the security alert to the network security team and await their instructions before taking any action on the IP telephony system. Option D. Analyze call detail records, CDR, and quality of service, COS, data associated with the affected calls and video sessions to correlate with the flagged IP address and traffic patterns. The correct answer is D. Analyze call detail records, CDR, and quality of service, COS data associated with the affected calls and video sessions to correlate with the flagged IP address and traffic patterns. Explanation. This scenario presents a common challenge in network administration, balancing the need for robust security with the operational requirements of a voice and video communication system. The challenge lies in interpreting security alerts within the context of a specific, regulated environment, ensuring that any remediation actions are both effective and compliant with the governing framework. The CIPTV2 exam focuses on implementing Cisco IP telephony and video solutions, implying a need to understand how these systems interact with network security and how to troubleshoot issues that arise from this interaction. The correct approach represents best professional practice because it prioritizes a systematic, evidence-based investigation. By correlating the security alerts with specific call detail records, CDR, and quality of service, COS metrics, the administrator can pinpoint the exact nature of the traffic anomaly. This allows for targeted troubleshooting, such as identifying a misconfigured COS policy or an unauthorized application consuming excessive bandwidth, rather than resorting to broad, potentially disruptive security measures. This methodical approach ensures that the integrity and availability of the IP telephony and video services are maintained while addressing the security concern. An incorrect approach that involves immediately blocking all traffic from the suspected IP address without further investigation is professionally unacceptable. This is because it fails to adhere to the principle of least privilege and due diligence. Such an action could inadvertently disrupt legitimate voice and video communications, leading to service outages and potential breaches of service-level agreements, SLAs. Ethically, it demonstrates a lack of thoroughness and could negatively impact user experience and business operations. Furthermore, without understanding the root cause, the security threat might persist or manifest in a different form. Another incorrect approach, such as disabling the firewall rule that flagged the traffic, is equally problematic. This action bypasses established security protocols and could leave the network vulnerable to actual threats. It represents a failure to follow established security incident response procedures and could have significant regulatory implications if the network is subject to compliance mandates regarding data protection and network security. The professional reasoning framework for this situation involves a structured incident response. First, acknowledge and log the alert. Second, gather all relevant data including network logs, CDR, and COS reports. Third, analyze the data to identify patterns and potential causes. Fourth, formulate a hypothesis and test it through controlled investigation. Fifth, implement the least disruptive solution that effectively mitigates the threat. Finally, document the incident, the actions taken, and the outcome, and review for lessons learned. This systematic process ensures that decisions are informed, effective, and compliant. Question 16. System analysis indicates that a large enterprise is planning to deploy a new Cisco IP telephony and video solution across its US-based facilities. The project team is focused on achieving seamless integration and optimal performance. Which of the following actions is most critical to ensure the deployment aligns with US regulatory frameworks and avoids potential legal ramifications? Option A. Rely solely on the IP telephony and video solution vendors' documentation and assurances regarding compliance with U.S. telecommunications laws and regulations. Option B. Prioritize the technical performance benchmarks and vendor-specified integration procedures to ensure the fastest possible rollout of the new IP telephony and video services. Option C. Conduct a comprehensive impact assessment that specifically evaluates the new system's adherence to FCC regulations for emergency services, accessibility, and data privacy, and integrates any necessary compliance measures into the deployment plan. Option D. Implement the new system using existing network security protocols without a specific assessment of the unique vulnerabilities of real-time voice and video traffic. The correct answer is C. Conduct a comprehensive impact assessment that specifically evaluates the new system's adherence to FCC regulations for emergency services, accessibility, and data privacy, and integrates any necessary compliance measures into the deployment plan. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of integrating new IP telephony and video services into an existing network infrastructure. The primary challenge lies in ensuring that the implementation adheres strictly to the regulatory framework governing telecommunications services within the specified jurisdiction, which for this exam is assumed to be the United States. Failure to comply with these regulations can lead to significant legal penalties, service disruptions, and reputational damage. The need for a thorough impact assessment before deployment is paramount to identify potential conflicts with existing services, security vulnerabilities, and compliance requirements. Correct approach analysis. The correct approach involves a comprehensive impact assessment that specifically considers the regulatory landscape. This includes evaluating how the new IP telephony and video services will affect compliance with FCC regulations concerning emergency services, like E911, accessibility for individuals with disabilities (ADA), and data privacy. A detailed assessment will identify potential conflicts, necessary configuration changes, and any required certifications or reporting to regulatory bodies. This proactive approach ensures that the deployment is not only technically sound, but also legally compliant, representing best professional practice by prioritizing risk mitigation and adherence to established legal frameworks. Incorrect approaches analysis. One incorrect approach would be to prioritize only the technical performance metrics of the new system without a corresponding regulatory review. This fails to acknowledge the legal obligations associated with providing telecommunications services in the U.S. Such an approach could lead to non-compliance with FCC mandates, such as those requiring reliable E911 services, potentially resulting in fines and service suspension. Another incorrect approach would be to assume that existing network security measures are sufficient for IP telephony and video without a specific assessment of the new service's vulnerabilities. This overlooks the unique security challenges posed by real-time voice and video traffic and could violate data privacy regulations if sensitive information is compromised. A third incorrect approach would be to proceed with the implementation based solely on vendor recommendations without independent verification against U.S. regulatory requirements. While vendor guidance is valuable, it may not encompass all specific jurisdictional compliance obligations, leading to potential oversights and subsequent regulatory issues. Professional reasoning. Professionals should adopt a structured decision-making process that begins with understanding the project's scope and its implications within the relevant regulatory environment. This involves identifying all applicable U.S. federal and state telecommunications laws and FCC guidelines. The next step is to conduct a thorough impact assessment, mapping potential technical changes to their regulatory consequences. This assessment should inform the deployment plan, ensuring that all compliance requirements are addressed proactively. Regular consultation with legal counsel specializing in telecommunications, law, and internal compliance officers is crucial throughout the project lifecycle. Question 17. Operational review demonstrates that a company is planning to integrate its new Cisco Unified Communications Manager (CUCM) deployment with a third-party video conferencing service. The existing network infrastructure is a single, flat network without any segmentation. The company handles sensitive customer data and is subject to U.S. federal regulations regarding data privacy and communication security. The IT team is considering several options to ensure secure and reliable communication between the CUCM and the third-party service. Which of the following approaches best addresses the security and reliability requirements while adhering to regulatory expectations for secure data transmission in the U.S.? Option A. Deploy a dedicated firewall between the internal network and the third-party service, configured with specific quality of service (QoS) policies to prioritize voice and video traffic and restrict access to only necessary ports and protocols. Option B. Extend the existing flat network to include the third-party service's connection points, relying on endpoint security measures for protection. Option C. Implement end-to-end encryption on all voice and video calls without any network-level security controls between the CUCM and the third-party service. Option D. Allow all traffic to flow freely between the internal network and the third-party service to ensure maximum bandwidth availability for voice and video. The correct answer is A. Deploy a dedicated firewall between the internal network and the third-party service, configured with specific quality of service (QoS) policies to prioritize voice and video traffic and restrict access to only necessary ports and protocols. Explanation. This scenario presents a common challenge in IP telephony deployments, ensuring secure and compliant communication across different network segments, particularly when integrating with legacy systems or external partners. The professional challenge lies in balancing the need for robust security with the operational requirements of seamless voice and video communication, all while adhering to the specific regulatory framework governing telecommunications in the United States, as implied by the context of Cisco certifications, often tested within a U.S. regulatory environment. Careful judgment is required to select a solution that is both technically sound and legally compliant. The correct approach represents best professional practice because it prioritizes a layered security model that is fundamental to network security and compliance. Implementing a dedicated firewall with specific quality of service (QoS) policies for voice and video traffic ensures that sensitive real-time data is protected from unauthorized access and performance degradation. This aligns with general principles of network security and the specific requirements for secure data transmission, often mandated by U.S. regulations like HIPAA for healthcare or PCI DSS for payment card data. Even if not explicitly stated in the exam syllabus, these principles are foundational. The use of a firewall also allows for granular control over traffic, preventing unauthorized protocols or ports from being used, which is a key aspect of network hardening and compliance. An incorrect approach that involves simply extending the existing network without segmentation fails to address the inherent security risks associated with inter-network communication. This could lead to a breach of sensitive voice or video data, violating privacy regulations, and potentially exposing the organization to significant legal and financial penalties. Another incorrect approach, such as relying solely on endpoint encryption without network-level security, leaves the communication vulnerable during transit between endpoints, especially if the network infrastructure itself is compromised. This overlooks the critical need for securing the network path. Finally, an approach that prioritizes bandwidth over security by allowing all traffic to flow freely directly contravenes security best practices and regulatory expectations for data protection, potentially leading to data exfiltration or denial-of-service attacks that disrupt critical communication services. Professionals should approach such decisions by first understanding the specific regulatory landscape applicable to their organization's industry and data types. This involves identifying any mandates for data privacy, security, and communication integrity. Next, a thorough risk assessment of the proposed network integration should be conducted, identifying potential vulnerabilities and the impact of a security breach. The chosen solution should then be evaluated against these risks and regulatory requirements, prioritizing methods that provide robust security, maintain service quality, and offer auditable compliance. Question 18. Which approach would be most effective in implementing a new IP telephony and video conferencing solution that integrates with existing enterprise applications while ensuring compliance with data privacy regulations and maintaining secure communication channels? Option A. Deploy the new IP telephony and video conferencing solution with minimal configuration changes to existing network infrastructure, focusing on rapid integration with enterprise applications and relying on default security settings. Option B. Prioritize the integration of advanced video conferencing features and unified messaging capabilities, deferring detailed security and compliance reviews until after the initial deployment to minimize disruption to end users. Option C. Conduct a thorough risk assessment. Design a phased implementation plan that includes robust security controls, data encryption, access management, and comprehensive user training, and perform regular audits to ensure ongoing compliance with data privacy regulations. Option D. Implement the new solution by leveraging existing network segments without additional segmentation, assuming that current security measures are sufficient to protect the new IP telephony and video traffic. The correct answer is A. Deploy the new IP telephony and video conferencing solution with minimal configuration changes to existing network infrastructure, focusing on rapid integration with enterprise applications and relying on default security settings. Explanation. This scenario presents a common challenge in enterprise IP telephony deployments, ensuring secure and compliant communication channels while integrating new services. The core difficulty lies in balancing the need for advanced features, such as video conferencing and unified messaging, with the stringent security and privacy requirements mandated by regulatory frameworks. Professionals must navigate the complexities of network segmentation, access control, and data handling to prevent unauthorized access and maintain service integrity. The correct approach prioritizes a phased implementation that meticulously addresses security and compliance at each stage. This involves thorough risk assessments, adherence to established security protocols for data in transit and at rest, and comprehensive user training. By isolating sensitive data flows and implementing robust authentication mechanisms, this method ensures that the deployment aligns with regulatory mandates for data protection and privacy, thereby representing best professional practice. It demonstrates a commitment to a secure and compliant infrastructure from the outset. An incorrect approach that bypasses security audits or deploys new services without proper validation poses significant regulatory and ethical risks. Such an approach could lead to breaches of data privacy regulations, such as those governing the handling of personally identifiable information, PI, or protected health information. 5. Depending on the specific industry and jurisdiction, failure to implement adequate access controls or encryption could result in unauthorized disclosure of sensitive communications, leading to severe penalties, reputational damage, and loss of customer trust. Another incorrect approach might involve relying solely on vendor default security settings without customization, which often proves insufficient against sophisticated threats and may not meet specific regulatory compliance standards. This demonstrates a lack of due diligence and a failure to uphold professional responsibility in safeguarding sensitive information. Professionals should adopt a decision-making framework that begins with a clear understanding of all applicable regulatory requirements. This should be followed by a comprehensive risk assessment of the proposed implementation, identifying potential vulnerabilities and compliance gaps. Subsequently, a detailed design and implementation plan should be developed, incorporating security best practices and compliance controls at every step. Continuous monitoring and auditing are crucial to ensure ongoing adherence to regulations and to adapt to evolving threat landscapes. Question 19. The review process indicates that a company has deployed two separate Cisco Unified Communications Manager (CUCM) clusters, one at its headquarters and another at a remote branch office. Users in both locations need to be able to place and receive calls to each other seamlessly, as if they were on the same internal network. The current configuration only allows for internal calls within each cluster. The network administrator is tasked with enabling reliable call routing between these two CUCM clusters. Which of the following approaches best facilitates robust and scalable call routing between the two CUCM clusters? Option A. Configure a SIP trunk between the two CUCM clusters and define route patterns and route lists that utilize this trunk for intercluster calls. Option B. Attempt to route calls directly between individual IP phones across the WAN without any specific CUCM intercluster configuration. Option C. Configure only internal route patterns within each CUCM cluster, assuming that the underlying network connectivity will handle intercluster call routing. Option D. Ensure all endpoints in both locations are registered to their respective CUCM clusters and assume calls will automatically traverse between them. The correct answer is A. Configure a SIP trunk between the two CUCM clusters and define route patterns and route lists that utilize this trunk for intercluster calls. Explanation: this scenario presents a professional challenge due to the inherent complexity of implementing and managing Cisco Unified Communications Manager, CUCM, in a regulated environment, specifically concerning call routing and intercluster communication. The need to ensure seamless and compliant call flow between geographically dispersed sites, each potentially with its own regulatory considerations. Though for this exam, we assume a single, consistent regulatory framework, requires a deep understanding of CUCM routing mechanisms and the implications of configuration choices. Careful judgment is required to balance technical functionality with adherence to established protocols and potential service level agreements. The correct approach represents best professional practice because it directly addresses the core requirement of establishing reliable intercluster communication for call routing. By configuring a SIP trunk between the clusters and then defining route patterns and route lists that utilize this trunk, the administrator is leveraging the most robust and scalable method for intercluster voice and video traffic. This method ensures that calls can be efficiently routed between the two CUCM clusters, respecting the defined call routing logic. This aligns with the principles of effective network design and implementation, ensuring service availability and performance. An incorrect approach that involves attempting to route calls directly between endpoints without a proper intercluster trunk mechanism would fail because it bypasses the centralized call processing and routing intelligence of CUCM. This would likely lead to call setup failures, inability to resolve extensions across clusters, and a complete breakdown of intercluster communication. This is a fundamental failure in implementing a unified communication solution. Another incorrect approach, such as relying solely on device registration without explicit routing configurations, would be insufficient. While devices might register, the system would lack the defined paths and rules to actually route calls between them across different clusters. This demonstrates a misunderstanding of how call routing is managed in a distributed CUCM environment. A further incorrect approach, like configuring only internal route patterns within each cluster without any mechanism to connect them, would result in calls being confined to their respective clusters. This fails to achieve the objective of enabling communication between the two distinct CUCM deployments, rendering the intercluster connectivity requirement unmet. The professional decision-making process for similar situation should involve a systematic approach. First, clearly define the functional requirements, e.g., intercluster calling. Second, identify the appropriate Cisco technologies and features designed to meet those requirements, e.g., SIP trunks for intercluster communication. Third, consult the relevant Cisco documentation and best practices for implementing these features. Fourth, consider the impact of the configuration on the overall network and user experience. Finally, thoroughly test the implementation to ensure it meets all requirements and operates as expected. Question 20. The analysis reveals that a Cisco Unified Communications Manager administrator is implementing a new PSTN integration using an ISTN PRI interface. The administrator needs to ensure that call setup and teardown messages exchanged between CUCM and the PSTN gateway are correctly interpreted and processed to maintain reliable call connectivity and adhere to U.S. telecommunications regulations. Which of the following configuration approaches best ensures proper interoperability and compliance for this ISTN PRI integration? Option A. Focus solely on configuring the media termination points on CUCM and assume that the signaling aspects of the ISTN PRI interface will be handled by the PSTN gateway without explicit configuration on CUCM. Option B. Prioritize the rapid deployment of the ISTN PRI connection by using default CUCM settings and deferring detailed interoperability testing until after the system is live. Option C. Apply a generic ISTN PRI configuration to CUCM, assuming that the PSTN gateway will automatically adapt to standard signaling protocols without specific parameter alignment. Option D. Configure the ISTN PRI interface on CUCM with parameters that precisely match the signaling and bearer capabilities expected by the PSTN gateway, and verify that the gateway's dial peers are configured to reciprocate these settings for seamless call routing and termination. The correct answer is D. Configure the ISTN PRI interface on CUCM with parameters that precisely match the signaling and bearer capabilities expected by the PSTN gateway, and verify that the gateway's dial peers are configured to reciprocate these settings for seamless call routing and termination. Explanation: the analysis reveals a scenario where a Cisco Unified Communications Manager (CUCM) administrator is tasked with implementing a new call routing strategy that involves integrating with a third-party PSTN gateway. The challenge lies in ensuring that the call setup and teardown processes adhere to the specific signaling protocols and interoperability requirements mandated by the regulatory framework governing telecommunications in the United States, as implied by the exam's focus on U.S. regulations. This requires a deep understanding of how CUCM interacts with external gateways, particularly concerning ISTN PRI configurations and the interpretation of signaling messages like Q. 931. Administrator must balance the technical requirements of call routing with the need for compliance, ensuring that calls are established and terminated correctly without violating any service provider agreements or regulatory mandates. The correct approach involves meticulously configuring the ISTN PRI interface on the CUCM, ensuring that the signaling group, call routing, and media termination points are aligned with the specifications of the PSTN gateway. This includes verifying the correct DTMF relay method, the appropriate signaling mode, e.g., PRI, and the precise configuration of dial peers on the gateway to match the dial plan originating from CUCM. This meticulous configuration ensures interoperability and compliance with U.S. telecommunications regulations, such as those overseen by the FCC, which govern the proper functioning and interconnection of telecommunications services. Adhering to these standards prevents service disruptions, ensures accurate call billing, and maintains the integrity of the public switched telephone network. An incorrect approach would be to assume that a default configuration for the ISTN PRI interface on CUCM will automatically interoperate with any PSTN gateway. This overlooks the critical need for specific parameter matching, such as the bearer capabilities, channel identification, and signaling information elements within the Q. 931 messages. Failure to align these parameters can lead to call setup failures, dropped calls, or incorrect call routing, potentially violating service-level agreements and regulatory requirements for reliable telecommunications service. Another incorrect approach would be to prioritize speed of deployment over thorough testing and validation of the ISTN PRI configuration. This could result in subtle interoperability issues that manifest under load or during specific call scenarios, leading to service degradation and non-compliance with the expected performance standards for telecommunication services. The professional decision-making process for similar situations should involve a systematic approach. First, thoroughly understanding the technical specifications of both the CUCM and the PSTN gateway, paying close attention to their ISTN PRI capabilities and limitations. Second, consulting relevant Cisco documentation and the PSTN gateway vendors' interoperability guides. Third, meticulously planning the configuration, mapping dial plans and signaling parameters. Fourth, implementing the configuration in a controlled environment, followed by comprehensive testing that simulates various call scenarios, including inbound, outbound, and internal calls. Finally, monitoring the system post-implementation to identify and address any emergent issues, ensuring ongoing compliance and optimal performance.